to solve another Leetcode problem. So it's gonna be 1644, lowest common ancestor of binary tree 2. So the only difference from the problem 1 is that for this problem, the P and Q may not exist. So for example, this is 5 and this is 1. The lowest common ancestor is going to be 3. And for the second one, P equal to 5 and Q equal to 4, and the LCA is going to be 5. And for the third one, P equal to 5 and Q equal to 10, but this 10 is not inside the binary tree. This means it does not exist, and we're going to return a none. So I'm going to use the previous idea. So firstly, I'm going to imagine that P and Q will exist, and I'm going to check how can I find the lowest common ancestor. And second of all, I'm going to use another DFS to check if this P and Q exist inside the binary tree. If it's not exist, I'm going to return a null immediately. Otherwise, I'm going to use the DFS to find where it is. Yeah. So first of all, I'm going to define a DFS. So for this DFS, I'm going to check the LCA if P and Q exist. Yeah, so I'm going to check if not inside P and Q. So I'm going to return this node. So if not, it means it's not exist. So I'm going to return a none. And then I'm going to prepare the left and the right side of the binary tree. It's going to be the not dot left and the DFS and not dot right. Yeah. So if left and right exist, it means I can find it. So I can return this node immediately. So otherwise, if left or right, so I'm gonna return the left or right. Yeah, I mean if left side exists, so I'm gonna return this left. So I'm gonna continue to check if I can find the left and right. But definitely this DFS is just imagined the LCA must exist. So otherwise, if it's not exist, so I'm gonna use another DFS to check if it exists or not. So I'm gonna use a DFS 2. Inside, I'm gonna give a node and a result array. This result array gonna be an empty array. Yeah, so finally I'm gonna call this DFS 2. So if so I'm gonna return the DFS with root. This means it exists. So if DFS 2, it means if it exists. So I'm gonna call the root node with an empty array. So otherwise, I'm gonna return a none. Now I'm gonna focus the DFS 2. Basically, this DFS is to check if the node P and Q exist. So I'm gonna use a pre-order traversal. So if not in P and Q, so I'm gonna put it inside of the result array. So the result is gonna append this node. Then I'm gonna run the DFS 2 with the not dot left, because this is basically the pre-order traversal. Yeah. So for pre-order traversal, I'm gonna check all the nodes inside of the tree, and if it equals to P or Q, I'm gonna put it inside of the result array. And finally, I'm gonna check the result array if it is equal to 2 or not. If it is equal to 2, it means P and Q must exist. Yeah, because all the nodes is unique, and we have to check from here, P not equal to Q, and all the nodes value are unique. So this means, we can directly use this P and Q. We can directly use the node, and for all the nodes, it is also unique. Now let me just run it to check. As you can see, it works. Now let me submit it to check. Yeah, as you can see, it passed all testing cases, and it is quite slow because we use the 2 DFS. And for one DFS, it is ON time. Another DFS is another ON time. So basically, the time complexity is ON, and it's dependent on the number of nodes. It is 10 to the power of 4. So that's for it. Thank you for watching. See you next time.